Hello class, we are going to review concentrations in the solid phase, in particular the soil compartment. In terms of concentration expressions, there's really only one concentration expression we deal with in the solid phase, and that's a mass ratio, mass of chemical per mass total. We can express it in some different units. We can express it as a percent, milligram per kilogram, and we'll see in a moment that that's equivalent to parts per million, and microgram per kilogram, which we'll see is equivalent to parts per billion. So here's an example for us. A 1 kilogram sample of soil contains 1 microgram of silver, 10 milligrams of magnesium, 15,000 milligrams of potassium. Express the concentration of silver in micrograms per kilogram and part per billion. Express the concentration of magnesium in milligram per kilogram and part per million. Express the concentration of potassium in milligrams per kilogram, part per million, and percent. All right, let's look at silver. From the problem statement, we have 1 microgram of silver, we have 1 kilogram of soil, so there we go, we're check. 1 microgram silver per kilogram soil. To convert that to parts per billion, the first thing we need to do is have a mass ratio, and that mass ratio needs to have the same units in the numerator and the same as in the denominator. So we need to convert the micrograms of silver to kilogram. So there's 10 to the 9 micrograms per kilogram. So once we've done that conversion, this expression here has, it's expressed as kilograms silver per kilogram soil. And now by definition, to express it as a part per billion, we need to take this overall expression and multiply it by 10 to the 9. And what we see is that the units of microgram per kilogram and part per billion are the same. 1 microgram of silver per kilogram of soil is equivalent to 1 part per billion of silver in the soil. We go to magnesium. From the problem statement, 10 milligrams of magnesium per kilogram of soil, check. Do the unit conversion of 1e6 milligrams in a kilogram. So now at this point we have a mass ratio of, in terms of units, kilograms of magnesium in the numerator, kilograms of soil in the denominator. By definition, since we're talking about parts per million, we multiply this by a million. 10 to the 6 is a million, and we get 10 ppm. So just like microgram per kilogram is equivalent to parts per billion, milligrams per kilogram is equivalent to parts per million. Potassium, we're going to do the same thing. 15,000 milligrams of potassium per kilogram of soil. We do our unit conversion of 10 to the 6th milligrams per kilogram multiplied by a million. 15,000 parts per million, or 15,000 milligrams per kilogram. Percent. So we use this same mass ratio where we've done the unit conversion. So we have kilograms of potassium in the numerator, kilograms of soil in the denominator. Now though, instead of multiplying by a million, we multiply by 100 to express it as a percent. And so 15,000 milligrams per kilogram is equal to 15,000 parts per million, and it's also equal to 1.5%. That concludes our lesson on concentration expressions for the solid phase. Next is the air phase.